Alrighty, our next set of problems here is 1-3-CW1, manipulating equations. And this is another Park style of how to use inverse operations to get what we want. We're going to focus most on the top part here, manipulating the equations in this video. And we're going to knock out a couple of these problems that we did in class here. I'm going to redo them again here online. So with problem number 1, it says a times x plus 7 squared plus d equals e. That's what's given to us. Our goal is to get x all by itself. We're trying to prove that x equals plus minus the square root of e minus d over a minus 7. We got to prove that it's the same equation here by getting x all by itself. So we're going to use our inverse operations to get x all by itself. So looking at this, our goal is to get x all by itself. I'm going to move that d to the other side first. So I'm going to subtract d from both sides of the equation. So we get a times x plus 7 squared equals e minus d. So all I did was subtract d from both sides of the equation. And then I rewrote it to make it nice and pretty. I simplified it. Remember, our goal is still to get x all by itself. So that means we can move this times a to the other side. And we do that by dividing by a to both sides. So you have x plus 7 squared equals e minus d over a. Now we have a squared. So that's just like what we talked about with the square roots and simplifying square roots and doing inverse operations of squared. Well, the inverse operation of squared is square root. The inverse operation of cubed is cube root. The inverse operation of to the 4th power is 4th root. But right here we have a squared. So to get rid of that squared and move it to the other side, we have to do square root. So we do square root to both sides of the equation. You get x plus 7 equals plus minus, because the square roots, you have the plus and the minus, square root of e minus d over a. And the last step is to subtract 7 to both sides. So I'll rewrite it up here. We get x equals plus minus the square root of e minus d over a minus 7. And we successfully got x all by itself. We proved it by showing each one of our steps. So that's the answer to problem number 1. Next up, problem number 2. Alright, here's problem number 2 here. It says r parentheses x minus 4 squared plus m equals e. And we're going to show all our steps to get x all by itself. That's our goal. We're trying to prove that x equals plus minus the square root of r minus m over r plus r. So we're going to do it step by step here. Our goal is to get x all by itself using our inverse operations. So we move the m to the other side by subtracting m to both sides of the equation. Our first line is our given. Then we subtract m from both sides. So we get r x minus 4 squared equals e minus m. Now, remember, our goal is to get x all by itself. So we have to use inverse operations to get the r on the other side. So we divide by r to both sides of that equation. R on both sides. So we get x minus 4 squared equals e minus m over r. You do square root. So you have x minus 4 equals plus minus the square root of e minus m over r. Then we add 4 to both sides. And we're going to get x equals plus minus the square root e minus m over r plus 4. And we proved it step by step. Next up is problem number 3. Next up here, we got problem number 3. Our goal is to get Q all by itself and prove step by step that that A is going to be all by itself. That's our goal, to prove that. Where A equals B minus N over Q minus 4 squared. So we got to use our inverse operation skills and try to get A all by itself. So looking at that, well, I know I can move my N right away to the other side. So we have A times Q minus 4 squared equals B minus N. Next up, it's A times, well, this is an entire term. I could actually move this entire term over to the other side. So I'm going to divide by Q minus 4 squared to both sides. Which is a little weird. You haven't seen really that much of that before. But you could take a whole term like that and move it over to the other side if A is what you're trying to get all by itself. So we have A equals B minus N over parentheses Q minus 4 squared. And we successfully then got A all by itself, and we proved it by showing all our steps. So that's problem number 3. Next up, we'll do problem number 4. Alright, here's problem number 4. We have B times S minus 6 squared plus N equals Y. Our goal in problem number 4 is to get B by itself and prove step by step of getting B by itself. So, that's what we've been doing before. Subtract them from both sides. You get B times S minus 6 squared equals Y minus N. And this is B times this entire term. We can move that entire term to the other side. We're going to divide it by S minus 6 squared to both sides. So we get then B equals Y minus N over S minus 6 squared. And that's how we successfully got B by itself, and we proved it. Where B equals Y minus N over S minus 6 squared. That's using our inverse operations. Get that all squared away. Last but not least, number 5. Alright, here with number 5. We got to get B all by itself and find out what B equals. We're going to have to prove it step by step here. Because they tell us what B equals on the bottom. So we have to prove that what we're given here to what we need to get with B equals. So let's do it step by step. Just like before, subtract N from both sides. So B times S minus 8 squared equals P minus N. Because they're not like terms, so we have to write it out like that. It's B times, so we have to divide by S minus 8 squared. So B equals P minus N over S minus 8 squared. First step was given. Next step was subtract N to both sides. Then I simplified. Then I divided by S minus 8 squared to both sides. And then I got my solution. That's the step-by-step for us 1 through 5 of 1, 3, CW1. Remember, if you have any questions, concerns, you can ask during class, or please actually come to extra help because it's very detailed oriented. Alright, have a good night.